We already looked at many problems, but there is still a lot to discover. Let's move to the next problem, the edit distance. We have two words and we need to calculate the edit distance between them. We have three operations. We can delete character, we can add character, and we can replace character. This problem is also known as Levenshtein distance. For example, we have Saturday and Sunday. The edit distance between them is 3. We can delete A, we can delete T from Saturday and replace R for N. And the Saturday will become Sunday. We can try to solve this problem using brute force, but the time complexity will be massive here and it will not be production ready. So we might want to try something that we already used to solve the coin change problem. We will use the table, but what will be our rows and columns and what we should calculate? For rows and columns we will use input data. It's two words. Let's see operations available. We can delete character, we can add character, and we can replace character. Each operation will cost us 1, but if letters are equal, then cost of replacement will be 0. So assuming this information, we can think about the base case. If we have two empty characters, then the edit distance between them will be 0. What will be the edit distance between empty string and S? It's 1, because we need to add character S to empty string or remove one character from string S. What will be the edit distance between empty string and SA? It's 2. Because we need to add character S and A to empty string or remove two characters from string SA. Knowing this information, let's fill our base case for each 0 row and 0 column. Now let's look at row 1 and column 1. What is the edit distance between two strings S and S? Our logic is telling us that edit distance is obviously 0. But we still need to calculate the value for this cell to build the formula. Let's try to apply all operations available and pick an operation with the minimal cost. Let's look at the deletion. To delete character, we should look at the cell on the left, row column -1. Cost of this operation is 1, and we already know that the edit distance between empty string and S is 1, so we need to add 1 plus 1 and get 2. Next operation is insertion. To insert the character, we should look at the cell on the top. Cost of the operation is 1. And we know that if we add S, we will also add the edit distance 1. So 1 plus 1 is 2. Next operation is substitution. But since the characters are equal, we don't really need to use substitution here. The cost of this operation is 0. We should look at the string that we already built at this point, row -1 and column -1. We already have all candidates, 2, 2 and 0. We know that minimal value is 0, so edit distance between S and S is 0. Now let's move to the column 2. To fill this cell, we need to calculate the edit distance between S and SA. As we can see, optimal operation here is to delete character. We need to look at the row column -1 and add 1. The result is 1. Let's formalize what we need to know to do for each cell. We need to calculate the minimum between cost of deletion, insertion, substitution, and if the characters are equal, then we don't need to do anything. Let's fill this row until the end. The optimal solution for the rest of the row will be just look at the previous column and add 1. Now we need to fill row 3. Let's take a look at the first column. We need to choose again among our 3 operations. The cost will be 1. For column 2, the cost also be 1. For column 3, the cost will be 2. For column 4, we again need to figure out what is the edit distance between SU and SATU. Our intuition says that it's 2, because we need only to delete character A and T. Let's fill this row until the end. Now let's fill row 4, row 5 and row 6. The last cell will be our answer. Now let's do the implementation. Let's initialize our table with the size of the rows and columns will be the length of the strings. For the next step, we need to fill the base case distance between empty string and each character of the word. Now let's iterate through the table and calculate each cell using our formula. First we will calculate the replacement cost and then we will take minimum from deletion, insertion and replacing characters. Finally, we need to return the last cell as an answer. The time and space complexity here will be O and by M, where N and M is the length of our strings.